Hello, everyone. Good morning. Welcome to day 3 of data analytics with our workshop. So today we'll be moving on to data analysis and visualization. So the first step before you can visualize your data or draw out insight from the data is for you to import your data from where you saved it. So before your data can be used in R, it needs to be imported and saved as a variable. Then we'll be using the read.csv function to read our data because our data is a comma separated value data. Its extension is .csv. So we'll be using read.csv to read it. So let's copy this code, then run. So this is the code. So we'll be running it. So for us to view our data set, use the view function. The view function will help us in viewing our data in a table format, the complete data set in a table format in another tab. So this is the data we're reading. Or that's the we can use the head function. So the head function will give us the first 6 rows of the data set. So these are the first 6 rows of the data sets. And again, data can also be exported using the write.csv function. So in case you want to subset our data, we want to take certain columns from it, like this one now. We're interested in the column 2, column 3, and column 4. So we'll be saving that one in the subset variable and later export it to a subset.csv file. So let's view the subset data first. Can view it using the view function. The subset. This is it. So the column 3, it's gotten from the sales data. Column 2, column 3, column 4. That's the column warehouse, column client type, then column product line. So this is it. Warehouse, client type, then product line, excluding the other variables. So then we'll be writing it into subset.csv file using the write.csv function. So I can it's here now in the directory, in our working directory. So when we go to your working directory after doing this, you see the file stored there. So you can check for the descriptive statistics using the summary function. Remember, I used the summary function yesterday when we were looking at some this thing. So let's get the descriptive statistics of the numeric variables. So this is the descriptive statistics. The variable the sales data set itself has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 columns, 8 different variables. So we have 1, 2, 3, 4, 5, 6, 7, 8. The 8 amongst all of them, 1, 2, 3, 4, 5. 5 of the variables are categorical, while only 1, 2, 3. 3 of the variables are continuous variables that have this. So The quantity variable, the minimum from the quantity variable is 1. The first quantile is 4.0. The median is 6.5. The mean is 9.395. The maximum is 40. Therefore, unit price to total. But these other ones, they are categorical variables. That's why it's not system, because their class is character. Meanwhile, these ones, their class are the variable data type of these columns are in numeric. So that's why it breaks out this thing. So for the other ones, it will just bring out the length of the data. So then let's find out the total amount of all sales made. So the total amount of all sales made, we'll be finding that out using the sum function. This is the code. So remember, there is this total column here. Let's look at it from here. So this is the total column for central on this state of client type retail, product line, miscellaneous, having its quantity with the unit price being 16.85. So the total is 134.83, and like that till the end. So we now want to look for the sum total, the total of the sales, the total amount of all sales made. So that's 289,113. So we've been able to look for the sum total of this, the whole column here, the whole column total. So that's the total of the whole column total. So that means the total sales made using this data set is 289,113. So if I'm also interested in having the total quantity ordered, that would just be sum into sales quantity. Remember, I said yesterday, I use the square bracket. Use the square bracket to index. So either you use the index number of the column you're interested in, or you use the variable name of the column. So either I use quantity or I use 1, 2, 3, 4, 5, 5. It will still give me the same answer. So that's 9,395. Or I do sum of sales data of 5, column 5. So that's the same. It's giving me the same number. That's 9,395. Or using the $sign as we did yesterday. For the $sign, you can check for the total amounts of the units pricing. So sales using this $sign. So by using the $sign to the RStudio will give you all the columns there. So that's, I'm interested in the unit price. I've checked and clicked it. So this is the total amount of the unit price, in case you're interested in 30,322. So moving on now. Let's check for the total payments by cash. The total payments by cash. The total payments by cash. For the total payment by cash, remember, sales $sign payments. This is a column, remember? So that means the column payments from the sales data site. So that means these equal to double equal to sign. Yesterday we talked about it being used for comparison. So it says where sales the payment sales, the payment column from the sales table is equal to cash. So in that when there's this, then look for the total. So this is what the code is saying. So when for all the payments made by cash, the total sum is 119,199. So with this, let's look for, use the unique function in case you want to know the different levels in a column. So for this, we have credit card, cash, then transfer. So from the payment column, the payment column has 3 different values. It's either you have it as a credit card, or you make your payment by cash or by transfer. So then if we're interested in the total sum of payments made by transfer to, that'll be where equals to transfer. Remember to note the wordings very well. Where there is capital, write it capital. Remember, R is case sensitive. So the total of that. So for all payments made by transfer, the total is 159,642.3. So now we want to get the most expensive item by unit price. The most expensive item by unit price. So the code here says sales from the sales table, the unit price column from the sales table equals to 66.62. So 66.62 is the highest sales, highest unit price. We got that from the maximum from the summary of the data sets got earlier. So the maximum from the unit price columns is 66.62. So that's why it's equal to 66.62, because we're looking for the item, the most expensive item by unit price. So we referenced it using the amount of the unit price, which is 66.62 being the most expensive. So for the most expensive item, just have one, and that's item number 628. The date is 27th of July 2021. The warehouse where this occurred is Central. The client type is a retail client. The product line is engine. The quantity bought was 6. The unit price is 66.62. Then the total was 399.71. And the payment was made by credit card. So total sales made in each warehouse. Let's do for total sales made in each warehouse. So for the warehouse Central, using the sum function, this is it, the sales table. So the warehouse column from the sales table. Remember earlier, we used the $sign. We can also use the square brackets as we did earlier here and here. So where the warehouse value is Central in the sales data sets. So looking for the total, the sum total of Central. So at the warehouse, at the Central warehouse, the sum total of sales made is 441,982.9. So then this was Central for, let me use unique to get the different levels in the warehouse column. So we have Central, North, then West. So, okay. So this is for central. So for west, I'll change this central to west. So the sum total of all sales made at the west central, at the west warehouse is 446,926.49. Then also for the other warehouse, which is north, for north, I'll just change this central again to north. The N is in capital. Remember, R is case sensitive. So that's 100,203.6. So that's the total amount of sales made at the north warehouse. At the north warehouse. So now, data visualizations are performed in R using the ggplot2 package. In R, we have several packages. A package is unique to some actions and operations to be carried out. So when it comes to data visualization in R, ggplot2 is the package you have to use. So the first thing you should do is to install this package, install.packages. Use the install.packages, and that's the name of the package you intend to install is ggplot2. Oh, ggplot2. So you write out this first, put it in double quotes. But since I have it installed already, let me comment it out. I'll just use the library function to load the package. ggplot2, okay. So then I'll run. So with this, I've activated the ggplot2 package, asking it to start running. If I fail to run this package here, the codes that I write will flag out errors. So now, let's find the frequency of sales made by warehouse. You know, visuals are quickly interpreted faster than words. So when you want to report to some certain stakeholders, or you want to give your report to your findings to the audience to see, it's better for you to make it in a report in visuals than words. So that's one of the reasons it's very important to master the data visualization. So using the ggplot function, say where our data equals sales, then the mapping says AES, the X axis is warehouse, the Y axis is total, then filling it with the warehouse variable. Jump call. So there are different types of visual that you can use, that you can draw from the ggplots. You can do scatter plots, bar charts, pie charts, column charts, and the like. So for this one, we're interested in having it as a column chart. So run it. So come down here to the plots tab here. So this is the visual. So this is for central, this is for north, and this is for west. So this means that the total amount of sales made at central warehouse is the highest, followed by north, then followed by west. So can we see fast? We've quickly interpreted it. So remember, this jump call is used to specify the type of visual you are interested in drawing. The next one, let's also find the total sales made by each client from the various warehouses. So from all the warehouses now, we want to classify the total amount made by the client type to know which client type exactly are making the highest amount of sales at the end of the day. So using our data is sales, the sales variable data. So then the X column will be client type, the X axis will be client type, the Y axis will be total, then filling it with client type variable. So this field will help us in, yes, we're using jump code to make it a bar chart. So from here we have it that the wholesale clients, the clients that buy in wholesale have the highest total amount of sales at the end of the day, followed by the retail. Followed by the retail. So let's also see the payment system with the highest transactions. The payment systems and the payment system with the highest transactions. So here our x-axis will be payment, because we want to visualize the data with respect to the payment type here. So the total amount received from cash is smallest, then that of credit card is more than that of cash, and that of transfer is high. That means most customers prefer to make their payments by transfer. So from this, say this is your data sets, then after you're finished visualizing it, you get to know this. You make sure that the network of your bank is not fluctuating, because if these clients say they are not interested in any other payments aside from transfer, then you have a problem if the transfer system is whack. So we've come to the end of this session today. So let's have a recap of what we did. We imported and exported. We imported and reported our data from data file from the working directory where it was saved, from the part where the data was saved, using the read.csv function. Then we also exported a subset of the data to the subset variable, then use write.csv function to export it to the subset.csv file, which is equally in our current working directory. Then we use this head function to get the top 6. We're here to get the top 3 rows of the data sets. Then we use a summary function to get the summary statistics of data sets, especially for the numeric variable types. Then we analyze our data, getting the sum total of the whole data sets, then classify it by cash payment type. Then we got the most expensive item by unit price. We fished it out. Then we're able to get the total sales made in each of the warehouses. Then visualize each of the we visualize getting the total from the warehouse, total by client type, then total by payment type. So with this, we've come to the end of the session. It's nice having you here.